Although we live in a world of software, server hardware still matters, from the data center to the cloud to the edge. This episode of the Tech Field Day podcast features Scott Shaffer, a VP and Chief Technologist at HPE, discussing the evolution of the server with Jack Poller, Vuong Pham, and myself, Stephen Foskett. Servers really are still relevant, and maybe more relevant than ever. Welcome to the Tech Field Day podcast, where we bring together a group of IT technical experts to discuss a single idea about key concepts in the industry. This podcast features a variety of perspectives from members of the Tech Field Day delegate community and is often recorded in association with one of our events. Tech Field Day is part of the Futurum Group, and this podcast is also published on our sister company's site, TechStrong TV. On this episode, presented by HPE, we're discussing server hardware. Is it still relevant in this age of cloud and platforms and software eating the world? Before that discussion, though, let's meet who's on the panel today.
Hi, I'm Jack Poller. I am founder and principal analyst with Paradigm Technica. We are an industry analyst and research firm focusing on AI and cybersecurity.
Hi, I'm Vuong Pham. I'm with Nth Generation. I'm a senior solutions architect. We are solutions provider. We provide hardware, software solutions for many customers, public and private.
And howdy, I'm Scott Shaffer. I'm the Vice President of our Advanced Development Group here and the Chief Technologist for our compute organization. That's the group in Hewlett-Packard Enterprise that develops our ProLiant and Synergy and Superdome class servers. It's great to be here.
And I'm Stephen Foskett, organizer of the Tech Field Day event series, including the special event that we're holding with HPE's ProLiant team today as you are listening to this podcast. So let's start off by talking to the team here. You know, we live in the world of cloud. We live in the world of everything as a service. Why does somebody really care about server hardware anymore? Scott?
Well, I mean, obviously the software's got to run somewhere, and so we care. But I say that somewhere part because I think that matters. The location actually really matters. We speak to, or I end up speaking to a lot of customers where that location is critical, and especially being really close to the data, being able to access whatever you need whenever you need it to either run your AI or to build your services or to build whatever business solutions you're trying to build there. Being able to being close to the data is very critical, and I think we know that it's not cheap or effective to backhaul all that to cloud all the time, nor do many customers kind of want to have their proprietary data up in someone else's service. And so, we definitely see a huge and continued interest and growing interest in making sure that the customer has on-prem server hardware for whatever they need.
Yeah, so it's in part it's a manifest destiny. You have control of your environment fully. You have control of how long you use it, what you use it for, everything, and it's at your control and your disposal. You don't have to be at anyone's whim. You have better economics. You have better control. So why not? You have to invest in yourself and not be at someone's whim. So that's important in my opinion. And some topologies don't allow a public cloud, to be honest, or any other hyperscaler.
Well, you talk about location and you talk about sort of, control and, Vuong, you said, why not? And I used to look at the world and say, why invest in the hardware, right? It's a huge capital expense, and a lot of what companies were doing was migrating their capital expense to OpEx and moving to the cloud, and that changed the budgeting equation. And then we sort of divided the world into companies that were born in the cloud that started out with a cloud footprint and would never have anything on premises. And then you had the older companies that had an on premises footprint that they would always keep running because the cost of sort of migrating the entire environment to the cloud didn't make sense. But I think the age of AI is changing that. And, Scott, you mentioned the need to have your compute close to your data rather than invoking the data transport cost, which is both a time and monetary cost. And so I think as more and more companies start doing and figuring out what they can do with AI beyond just simple chatbots, there's going to be a lot more edge computing and a need for not, for high density, high power compute in these weird remote locations. So I think in that case, sort of servers really do matter now, and it's no longer sort of a why do we care? It's of course we care.
Well, yeah, I agree with you. Workflow is important. Understanding our data, understanding how we consume our data, what our competitors doing with their data. You may be just a service provider, and that's important for its own mission. But when it comes down to it, even your service provider services has competition. And if other people, privacy issues, there's all those reasons are reasons to keep hardware relevant in your space, whether it be your own data center, control that at a co-location, but it's still yours, and you have, again, I'll re-echo the fact that it's you have control, and then that's, it may sound crazy, but it's not. It's just something you have to be cognizant of it, and controlling cost, controlling access, etc.
Well, and we see plenty of systems now. It's funny you mentioned the edge, right? Because I mean, I say funny because everybody defines edge slightly differently. I talk to some cloud providers, and the edge is a colo in your city. Okay, that's not what I mean. What I mean at the edge, and by the way, but I don't mean all the way out to your house. That's a little too far for us. When we talk about edge from a compute perspective, I mean, we're seeing servers go in at retail locations, multiple servers now at retail locations. We see servers going in at distribution centers, distribution warehouses. We see servers going in at manufacturing locations. We see them at sites like out at oil rigs. We see them out at uh, really just base of cell towers. Obviously, it's like you see them in all kinds of locations. Again, almost exclusively because you need the proximity to the data, right? Again, just backhauling all of it is too much. But yet you absolutely want to process it. We're seeing lots and lots of different kinds of sensors. I'm just going to use the word sensor. You can insert whatever your favorite kind is there, from cameras to voice to temperature. There's all kinds of stuff, but we're seeing all kinds of sensors at these locations that our customers really have to be able to uh, uh, collect all the data, collect all that telemetry, analyze it, and then act on it locally. And that can only be done, with systems right there.
Well, I think you hit it on the nose, Scott. Telemetry, data, those are those are pervasive in our society demands and our consumption of information. When you go somewhere, you ask a question at a point of sale, you want to know a lot of information. Where does the information live? If it's too far away, it's in somebody's file box, or in a granite mountain somewhere. It's going to be something that you want access to, right? And people don't have the patience. They want the information yesterday. They want it immediately at their fingertips disposal. So AI is empowering that, because that does the analytics. We have smarter systems at the edge, which actually enable customer experience, endpoint user experience, so they can get what they want to do, and make a better decision, because we're all about making better decisions. And how can we do it? We don't have access to the data to make information happen. So yeah, I echo that.
I think part of that is because we're looking at different use cases with different desires of business outcomes, right? And if you sort of roll back, I don't know, 5, 10 years, the business outcomes and the use cases were very, very simple. It was virtualization, and it was just running standard compute. And at that point, virtualization essentially said that your hardware platform was generic, right? It was a commodity piece, and ultimately, it really didn't matter what you were running on. Now we've gone beyond sort of virtualization and to another use case where what you're running on does matter because of all these other things we're talking about, the ability to have different sensors that might not be able to do it, the locality of data, the latency, the cost, the speed, the environmental conditions of the edge. This generic sort of place that's not really generic at all. It's very unique for each customer, and different business outcomes, different workflows. So in this case, as you start moving beyond sort of that generic use case of running virtualization, then the hardware really does start to matter again.
Yeah, I think that's the key point here is that when people think, oh, hardware doesn't matter, what they're thinking of is this sort of, I don't know, commodity space where you've got, generic hardware, whether it's virtualization or, containerization. Uh, and they're imagining this world where you just stack up, I don't know, 1U blade servers as deep as possible. And they are generic. And honestly, those are generic to some extent if it's used for that use case. But what we look at when we look at the server line of any large provider, especially the one we're talking to here, HPE, it's not generic servers, is it? I mean, these things are purpose built. You have different servers for different purposes. And yes, one of the purposes is stack them tall and have them be identical. But many of the other purposes are, memory intensive, IO intensive, accelerator intensive, edge servers, et cetera. These servers are very different from each other. And yet, of course, they're all built with many of the same components, but put together in meaningfully different ways. And Scott, that to me is what makes this world of servers still so interesting in that you look at them and you're like, okay, so they look similar, from a block diagram perspective, but look what they did there. They made this one have, all sorts of memory, or this one can handle all sorts of storage. And those two servers really are different, aren't they?
Well, you hit a big paradigm. The catch-22 of software driving hardware, hardware driving software, and use cases on top of that. And when you get with a manufacturer that is understanding that balance, that equation, and making accelerations on both sides possible, that's amazing. And that's the value that Hewlett Packard does. They'll listen to the customer, they'll see what the use case is. CXL is not dead. CXL is it's still there, and it's going to be more and more important. So it's you will see some new development with that shortly, and I'll just leave it at that. Scott, you're going to say something. I'm sorry. Go ahead.
Yeah, I was gonna say, we absolutely are building, some servers optimized for purpose. We recently introduced one that's designed for kind of these edge locations, and you say, what makes a server unique for an edge location? Why, wasn't it just a regular thing? You just, put it up. It's like, no, we built one that can be mounted to a wall. It can mount it under a desk, and yes, you can absolutely put it in a rack kind of form factor if that's what you want. But having different mounting options, as simple as that is something that we definitely heard from customers. They said, "Hey, I've got all kinds of different locations this has to go. Enable me to do that." We have the ability to have a filter physically on the front. I was working with one customer, and they sent me a picture of where the server was. The server's in the break room for the employees at the retail location, and so I was like, "Huh, what's in the atmosphere there?" I don't, I'm not sure. And so you don't want that kind of stuff in your server. So we have, filters that go on the front and make sure that they're protected, which is not something you worry about in the core data center, right? A data center, you don't care. It's all filtered specific air, but
You
on
know,
the edge, it's not, right?
you
So
think you don't
yeah.
manage that, but let me tell you, I cleaned the filter on my ProLiant ML110 the other day. It's been in a nice, clean environment. That filter was filthy.
Yeah, I got a lot of dust in the air usually, right? But then things like physical security, right? I mean, we want to make sure that somebody can't physically tamper with or take items out of it. Again, this is one of those things I think a lot of people don't think of because they're like, I physically control my data center. The racks are closed. That's great, but when you're out at the edge, right? Think about it. You got that hourly wage employee going along there. You just do. You need to actually secure these things physically in a way that perhaps we haven't. So that's like purpose built. But outside of even, I mean, I love talking about edge. We can talk about it all day. But outside of that, even in the core data center, and we're doing things to optimize, especially around efficiency. If I had of the buzzword for what I think we're doing now and in the future, it's going to be about driving efficiency. In the past, we've had other kind of things that we optimize for, like density. But I think that's not what we're hearing, right? We're not hearing from most customers they need that anymore. What they want is much more efficiency, especially from an energy usage perspective. And so we've been doing a lot to ensure that You can pick good, efficient options. If you need the absolute highest performance possible, I can give you that. And you don't care how much power it uses, that's great. But if you do care and you need more optimized for energy efficiency, power efficiency, we give you that too as well.
Well, you talk about edge servers, Scott. You know, I've been in those single closet areas, as they call it, data center, and the airflow is not what you expect. You might not be able to breathe, to be frank. And yes, it doubles as a HEPA filter. So you definitely have some environmental challenges, not just the compute challenges, not just the use case challenges for driving the software. Telcos have that.
Because the server, was the DL145 Gen 11, can operate at up to 55C. That's 100 and what is that? 130 Fahrenheit. So, because as you said, yeah, you go in these environments, they don't have data center class air handling, right? They got whatever air conditioning's in there, and sometimes the back isn't air conditioned at all.
Your ProLiant doubles as a HEPA filter, like I said,
Right.
right, Stephen?
Exactly.
Well, you talked about efficiency though, and there's a number of considerations for efficiency. You talked about power efficiency, and I think we've been very focused about that recently, with the amount of heat and power these things consume and generate. I think the other part of the efficiency is things like how do you manage your fleet of servers, right? And I think it's management and it's how do you secure it. And physical security is one, and the securing the firmware and guaranteeing the trust factor of your data center. You mentioned physical security and a minimum wage employee. When you look at these servers that are in retail location, one of my favorite retail locations is a grocery store, supermarkets, right? Your server ends up there's no server closet, there's no data center. It's the only office in the building is the manager's office, and it sits there with their paperwork, with everybody going in and out all the time, and no cooling, no heating, coffee spilled on it, all of those types of things. So anybody can come in and access it, can put a USB drive in it if it accepts USB drives, right? Can plug in a keyboard and mouse and screw around with it, pull disk drives out, all of those types of things. But if that's the environment it lives in, how do you ensure the security of the boot firmware, the operating system, all of those things? So I think that's another consideration where a lot of work you're doing, right?
I think you're redefining DLP there, Jack.
It's the world we live in today. It's a completely different world than a machine stuck in a data center.
100%.
Yeah, I mean, we spent a lot of energy with these ProLiant Gen 12s where we've introduced a new ILO 7. It's an ASIC design that we do ourselves. I think a lot of people don't know that. We develop our own ASIC here. We don't buy it from the market. Everyone else does that I know of. Every other vendor buys theirs, which is fine. But we develop our own because we want to make sure that it has, I always say, everything I need and nothing I don't. Right? I don't want to pay for anything I'm not using. So it's got everything that we need in there, including our new secure enclave, which is a new secure vault built into the ASIC itself. It's isolated from the rest of the ASIC from an access perspective, and then it has its own memory and its own storage, completely separate. But it's inside the package, so nobody can come along with a chip clip and clip on and extract any information. We use it to store all of the passwords, the keys, the configuration parameters, so none of that is exposed. And then we use that as well to allow us to make sure that all of the firmware that is on that platform, first of all, it's encrypted, it's managed by us, and it cannot be tampered with or modified in any way. And if it is, we instantly detect it. And depending upon what it is, we either shut the system down, alert you, all those kinds of good things to let you know something's not going right. But that capability is rooted all the way down into the ASIC itself. We call it silicon root of trust because it's built into the ASIC hardware. So there can be no tampering with the supply chain, nobody messing around with the server in transit and putting a different firmware on. You can't do any of that because our HPE's protection is built right into the actual ASIC itself. The very first it powers on, and the very first thing it does is load a little thing, we call the bootloader. that bootloader is protected by a digital signature in the ASIC. And so if it doesn't match, it doesn't load, just flat out doesn't load. And so then we chain the trust up from there, right? The bootloader then checks the next piece and ensures it's signed with HPE's keys, and off we go. And build up that whole root of trust, that it's rooted all the way down into the silicon. Certainly something that's unique to HPE.
Yeah, I think a lot of people think of ILO and other management capabilities of servers as being sort of KVM, right? I want to be able to reboot the thing. I want to be able to see what's on the screen, et cetera. But ILO is a lot more than that, because you can also do things like you can check firmware revisions, you can update the firmware, you can update the software, you can actually reconfigure the whole server from there. It's really hands-off management. And again, I have a ProLiant. I'm still only at ILO 5, but even with that old thing, right, I can do a lot without having to have hands-on on that server. In fact, I don't see a need to have a monitor on the thing, because you can do so much right there in ILO.
But also, to that point, adding to that conversation, the comm management that HP provides is something that's no one really talks about a lot in the field. It's new, relatively new, but it allows you to do upgrade lifecycle management for non-data center, for a disorganized, traditionally topology. And you have the ability for air gap, you have the ability for remote sites, all from one centralized location. And that gives you the ability to be agile and flexible to the changing business landscape and how people consume compute. Like you mentioned, Jack, you need power at the edge. Scott mentioned that as well. And then there's AI use case, POS systems. And I think that shows the evolution of computing, that, hello, this is Gen 12. They've been at it for a while, right? So hopefully some lessons have been learned and applied, and there's a good strategic direction. And I see some of that. Not all of it, but it's getting there, right?
Yeah, I think it's getting there, and I think what we're seeing now is a change again, as I was talking about earlier, a change in the use case from I need generic compute and I just need, my requirements are a processor and memory and some storage, to a much more comprehensive list of capabilities that I'm going to use, which is security, remote management, power efficiency, space efficiency, environmental conditions that are different, locations that are different, hands-on, hands-off management that's different than it used to be, and I think we're also going to see now capabilities that will help us do a lot more automated management as we bring AI into, or automation capabilities to reconfigure things on the fly depending on use cases and time of day and needs, et cetera. So it's going to be pretty interesting what's moving in the future for servers in general. And for me, Stephen, this sort of goes back to answer your question of do servers matter anymore? And I think I would have said no a year ago, and today I say absolutely it does.
Well, and then, of course, as we've kind of alluded to here, in this world of AI servers, there's an entire universe of accelerators and expansion cards. There's disaggregation with CXL. There's incredible capabilities in terms of memory and storage expansion. And all of this is leading us to a whole new world where not only do servers and server technologies matter, but server technologies are almost the defining thing that allows us to move into the future with some of these AI servers. You look at what's being delivered now to hyperscalers and to the AI factories, as well as to end users who are trying to do inferencing and so on. We've got an unprecedented level of power requirements, and power, of course, every watt you put into that server comes out as heat. So you've got to deal with heat. We're looking at incredible liquid cooling technologies. We're looking at just absolutely amazing demands being put on the hardware. And Scott, I know the teams that you have at HPE are dealing with this almost existential question of how can I possibly build a server that contains this fireball of a processor stack. How do I build a server that can support that?
Yeah, absolutely. When we talk, most customers that we talk to, they really they rely on air cooling. I mean, I love the liquid cooling stuff. It's really fun. And our HPC customers use it all the time, which is great. But most of the enterprise and certainly the medium-sized businesses, a lot of colos just don't have liquid as an option. So yeah, we have really interesting solutions for liquid, which can take the absolute highest wattage, highest heat parts that exist. But we also have to solve the problem for air. And we've been doing a lot of work on figuring out how to adapt the server design so that we can take on 10 650-watt power supplies, for example, 650-watt GPUs in a 4U server and still be able to cool them, plus cool the SSDs and the CPUs and the memory that's in those servers, right? We focus on those GPUs, which is very understandable, right? Because they're really high power, but we still have the CPUs and memory and SSDs as well that have to get. Oh, and as my friends always remind me, you got to always talk about those transceivers, right? The optical transceivers are also now power draws, and they also demand a lot of air cooling. So yeah, that's one of the things we focused on in Gen 12 is ensuring we have really strong options for customers that are doing AI that need those high wattage GPUs and being able to continue to use their air cooling for those solutions.
I remember going to Houston years ago and seeing some of the incredible stuff. I mean, you guys were engineering your own fans. You guys were, and obviously,
Yeah.
you've got an incredible
Yes.
work done on baffles and heat sinks and so on. I remember seeing all that stuff in person. And then I remember opening up a server and seeing it right there in front of me and saying, yeah, this stuff from the lab, here it is on the server.
Yeah, we take tours of people through our facility here in Houston, and a lot of people are surprised to learn that we have wind tunnels. By the way, I say wind tunnel, and immediately someone thinks that it's some big thing you can get a car or an airplane in. Our wind tunnels are very small. They're designed to put a server in, or they're designed to just put the fan assembly in. But yeah, we design fans, we design shrouds, we design all the baffling. Heatsink is a really hot topic, no pun intended, right now as we are working on, like I said, on trying to figure out how to do that. But one thing we tell customers, and it's really simple, is that losing density can often buy you a lot. If you think of the exact same server load, say an 850-watt load, just add it up, all the components in a 1U server versus a 2U, the 1U will consume an extra 100 watts for its fans alone to cool that 850-watt load. If you put it into a 2U server, it only takes 17 watts of fan power.
And then when you sit that on underneath the desk in somebody's little manager's office, right? It changes it changes it so it doesn't seem like you have a jet engine running under your desk.
My Alpha server under my desk was just fine. Thank you very much.
No, the acoustics are important. Yeah, we actually do care about that as well for those servers that are clearly designed for our edge locations. Yeah, because you don't know where they're going to end up, right? And you can't have it next to someone's head running like that. But no, we're trying to help customers understand that if they don't need density, don't pay for it. And what I mean is not paying me, paying the power budget. So you go lose density. It's a good thing. It'll really benefit you.
But I think you hit something very important there, Scott. Stevens mentioned, do you need servers? Well, yeah, we don't need commodity servers, Jack. We need engineered solutions, something with a lot of thought behind it that solves problems that you don't even think about and don't want to deal with: heat, power, longevity. So, and then when you have an organization that does look at the whole equation and solves that for you without you stressing about it, that's a win. That's a win right there.
And well, when you talk about engineering too, we're not just talking about the server itself. I mean, we're talking rack scale in these cases too. You mean, again, I have seen HPE's production floor. You guys are building whole racks for customers, right? I mean, it's not just it's not just servers that you're shipping.
Yeah, for sure. And I mean, not only racks but rows, and depending on what the customer needs, right? We have HPC systems which are multiple rows and can consume thousands of servers and tens of thousands of GPUs. We can build everything from yes, one server all the way up.
You guys are the number one supplier in HPC, right?
We are, and we are the top of all the big charts in terms of the best and the best supercomputers built, from Frontier to El Capitan to as the most recent two. But the first, some of the first and largest supercomputers ever built.
Incredible. Wow. So I think that as we're kind of getting here on in the episode, honestly, I think all of us are of agreement that servers still matter. I mean, that's why we're coming out here, right? That's why we're flying to Houston to visit HPE and learn a bit more about what they're doing. I almost said HPC. I guess we're visiting HPC too. Learn about what you're doing in HPC and AI and Edge and so on. Jack, what are you looking for in a conversation with HPE about servers?
I'm looking to see how the conversation has moved from what used to be server consolidation to really now server expansion, and what are all the different ways HP is meeting the customers these new use cases, and in particular thinking about all these various use cases. How are we going to secure servers and the server environment? I'm big on security, big on AI, and these are the things I think that are going to drive computing in the near future. And so, what is HP doing to meet these customer requirements and the new workflows and new ways of thinking about the computing world?
How about you, Vuong? I know that you know the HPE product line very, very well, but what are you learning? What are you expecting to learn here?
I want to see some of the people behind the scenes. I want to see their thought process, what drives them, what motivates them, and how they bring that to the HP product line, because that ethos is so important, and that's part of that culture of HPE. It's always been engineering, and people don't get it, and I think they need to really leverage that to help people understand that HP does care about your compute requirements, care about your mission, your outcome, and this is why. It's just, that's not a need to copy this, copy that, and we'll just tear apart. And it's more than agnostic. It's purpose built. So we need to help them understand it's purpose built, so we can derive the outcomes that are expected and exceed their expectations in most cases. Because how old is your little ProLiant, Steve? It's probably like and it's still chugging along, right?
Oh, come on. It's a Gen 10, man. It's not that
All
old.
right. I've
And
seen uptimes, amazing uptimes with HPE servers, and it's like, again, it's the balance between software and hardware and how they're really engineered well. So kudos.
And Scott, I guess what's your message? So when this episode airs, it will be the day of the event. We will be coming live on LinkedIn, on TechStrong TV, and so on. We're going to be posting these videos on YouTube. What do you want the audience to learn about what HPE is doing in the server market?
Well, yeah. What I'm hoping is that they get a sense of that. We really do care about building the best server system possible. That we work hard to engineer it. It is by design to be secured. It's by design to be optimized. It's by design to be automated, so that it can fit in. All the servers we build can fit all kinds of different locations, as well as, of course, core data centers, and be the best solution we can build. I mean, our whole goal, we really do believe that we build the best servers in the world, and I hope that comes across.
Excellent. I mean, I think it's well, I've had very good experiences with HPE ProLiant. Let me just say that. Thank you very much for showing this, and I'm very glad that we are able to kind of give people a look inside, like Vuong was saying, inside the factory, inside the server factory. Talk to the people, learn from the people who are doing the work, who are engineering these next generation servers. I know we're on Gen 12 now. Is it here, Scott? Can I put you on the spot? Is it going to be a Gen 13, or are you going to skip 13 like a hotel elevator?
People bring that up all the time. We absolutely are working on a next generation. What it gets named is kind of not up to me in engineering, but we'll see what the marketing team comes up with.
We'll see indeed. Well, thank you very much for this. And those of you listening, please do check out the Tech Field Day website. You can see a lot more detail about these servers, basically all of the things that we've been talking about here today, including a very, very sweet little edge server, the DL145 that was recently released. Check out on YouTube as well. If you've missed these things, you just Google Tech Field Day, HPE, ProLiant. You'll find the videos there. And I think you're going to learn something. Even Vuong, who knows more about this than me, is for sure is going to learn something. I guarantee it. So thank you for listening to this episode of the Tech Field Day podcast. If you enjoyed the discussion, please do subscribe. You can find us on YouTube. You can find us in your favorite podcast application. Please also give us a rating or review. We'd love to hear from you. This podcast is brought to you by Tech Field Day, home from IT experts from across the enterprise, which is part of the Futurum Group, and was recorded in association with our special Tech Field Day exclusive event that we're doing, which was sponsored by HPE. For upcoming episodes and more, please head over to techfieldday.com/podcast or find us on TechStrong TV or, as I said, in your favorite podcast application. We'd also have accounts on X, Twitter, Blue Sky, and Mastodon, so we'd love to hear from you from there. Thanks for listening, and we will see you next week on the Tech Field Day podcast.